So, good day everyone. So, by the way, I'm Christopher Layupan and I'll be presenting to you the reinforced concrete designing of one-way slab based on the NSCP code 2010 or 2015. So, before discussing the one-way slab, let us first define we already knew that reinforced concrete slab are large flat plates that are supported by reinforced concrete beams, walls or columns, by masonry walls, by structural steel beams or columns, or by the ground. So, ito yung absolute na palaan para ma-identify siya na one-way siya or one-way slab siya. So, yung one-way slab is kapag kinuha mo yung long side divided by short side, kapag yung result niya is naging greater than or less than or equal to 2 rather, and that is automatically one-way slab. So, ito na yun. So, sa one-way slab, usually supported on two opposite sides only. Bakit? Kasi, the bending dito sa one-way slab is in one direction only. So, that is perpendicular to the supported edges. So, may mga cases guys na gusto ko lang i-emphasize is may mga cases na yung long side over short side is greater than 2 or greater than or equal to 2, pero supported siya by beams on all sides or for edges rather. So, ayun, kung kino-compute natin is yung sagot niya is greater than 2, and pagtingin mo sa slabs niya is supported siya on all four edges. So, anong tawag nun? So, is it one-way or two-way? So, take note that yung masusunod nun is yung definition or yung absolute rule or rule niya is that yung ratio ng long side over short side, which is greater than or equal to 2. Kahit pa supported siya in all four edges, then that is still a one-way slab. No, kasi nga yung ratio is greater than or equal to 2. So, when it comes to one-way slab reinforcement details, yung ating main bars or main reinforcement is in one direction only. That is, so okay, wait. Take note. Sa one-way slab, ito yung longer side, ito yung shorter side. So, LY is the longer and LX is the shorter side. So, yung ating main bar dito is along the LX. So, sa kabilang direction is usually naglalagay din tayo ng reinforcement dyan. At yung usually or ang tawag niyan is distribution bar, or tinatawag din natin itong shrinkage and temperature bars. So, yun yung one-way slab reinforcement details. So, dito na tayo guys ngayon sa pag-design ng one-way slab. So, how? So, first, a one-way slab is assumed to be a rectangular beam with a large ratio of width to depth. So, ayun. So, kung napansin nyo guys, no? So, meron tayong rectangular beam dito. Kasi nga, pag nag-design tayo ng one-way slab, so, ina-assume natin siya na as rectangular beam. So, ibig sabihin guys, yung mga concept sa pag-design sa rectangular beam is i-apply natin dito sa one-way slab. Okay. So normally, kung rectangular beam siya, paano naman yung width? Kasi ang haba-haba at ang lapad-lapad ng span, diba? So, paano yung width? So, normally, a 1 meter piece of such slab is designed as beam. So, usually, ito yung strip. So, this slab is being assumed to consist a series of such beams side by side. Ito yon. So, for example, ito yung beam natin guys. So, kukuha lang tayo ng 1 meter strip at ito yung i-design natin as a beam. Or design natin as one-way slab. So, bali, yung design natin sa 1 meter or itong strip is same din siya sa design sa katabi dito nga side or dito din na side. So, ayun. Ganun lang. Madali lang yung pag-design ng one-way slab. So, unahin na natin guys yung slab thickness. So, paano ba tayo makaka-design ng thickness ng slab? Okay. So, the thickness required for a particular one-way slab depends on the bending, the deflection, and shear requirements. Okay. So, bali no, yung NSCP and yung ACI, like sa section 407.31 sa NSCP, at section 7.31 sa ACI provide minimum thickness of slab for which deflection calculations are not required. So, katulad ng pag-discuss natin ng ating depth or ng ating total depth sa beams such that hindi natin i-consider yung deflection. Dito sa slab ay meron din tayong ganon. So, according to NSCP 2015, nasa section 407.3 design limits or sa 407.3.1 minimum slab thickness, sabi dito, for solid non-pre-stressed slabs not supporting or attached to partitions or other constructions likely to be damaged by the large deflections. Overall slab thickness H shall not be less than the limits in table 407.1.1 unless the calculation deflection are satisfied. So, pag sinunod natin yung minimum, ibig sabihin is mas malaki compared sa minimum, then di na natin kailangan i-compute yung deflection. So, take note, pareho lang to guys sa nandun sa beam. So, iba to kasi one-way slab to. So, take note guys na this expression is applicable for normal weight. and f sub y is equal to 420. And if yung f sub y is, or fy is not equal to 420, so i-multiply natin yung expression na 0.4 plus f sub y or fy over 700 dito sa minimum niya. So, ayun na nga. Kung hindi naman guys, normal weight concrete, yung inyong concrete, then, for example, lightweight concrete siya, so, kailangan natin i-multiply to sa dito sa, or from this table, ng greater sa A and sa B, wherein sa A is 1.65 rather, minus 0.003 weight niya, and then si B is 1.09. So, pag lightweight siya, greater than aning nga formula, multiplied natin dito sa conditions. Okay, take note guys na kapag nagde-design tayo ng thickness ng slab, kailangan natin i-round up siya to the nearest 10 mm. Take note nyo na i-round up natin to nearest 10 mm. So that is for convenience sa mga construction workers, kasi ang hirap naman kasi yung like my decimals or my point something, so i-round up na lang natin yun as 10 mm. So ayun. So dito naman tayo guys sa shrinkage and temperature reinforcement. So bakit kailangan yon? So as concrete hardens, it shrinks, no? So pag tumigas daw yung concrete, nagsi-shrink daw siya, ibig sabihin nun is nagko-contract, or ibig sabihin lumiliit yung concrete. So it's like nagprito tag manok, 'di ba? Pag diprito siya, dry na siya. Like, 'di ba, magamay siya. So in addition, temperature changes occur that cause expansion and contraction of the concrete. So, di ba, alam naman natin guys, sa surveying, is like, kapag yung temperature is uminit, di ba, nag-expand yung ating materials. So, kapag naman lumamig yung panahon, then, nagko-contract yung ating concrete or ating material. So, ganoon din siya sa concrete. So, nagmamatter yung temperature and then yung shrinkage kapag nag-harden na yung concrete. So, kaya naglalagay tayo ng shrinkage and temperature reinforcement. So, when cooling occurs, the shrinkage effect and the shortening due to cooling add together. So, shrinkage and temperature still serve as mat steel in that it is tied perpendicular to the main flexural reinforcing steel and holds it firmly in place as a mat. So this steel also helps to distribute concentrated loads transversely in the slab. Yung shrinkage and temperature is placed perpendicular to sa ating main flexural reinforcing steel. So okay. So the NSCP code section 407.7.6 and ACI code section 7.7.6 states that shrinkage and temperature reinforcement must be provided in a direction perpendicular to the main reinforcement for one-way slab. So, nasabi na natin siya kanina guys na again, yung paglagay natin yung mga reinforcement, yung temperature and shrinkage and temperature reinforcement is always perpendicular to our main reinforcement. So for two-way slab, reinforcement is provided in both directions for bending. So ayun. So hindi na natin pag-uusapan yung two-way slab kasi yung kasama kong reporter na si Mervin Mamza, siya na yung magdi-discuss ng two-way slab. So, of course guys, kailangan din natin mag-estimate ng estimated slab weight. Kailangan natin siya as dead load. So, the weight of the slab to be selected must be included in the calculation of the bending moment to be resisted because the slab must support itself as well as the external loads. So sa SI units, again, same lang yapon sa ginagamit natin sa beam. So, concrete weight approximately 23.5 kN by cubic meter. So, dito tayo guys ngayon sa concrete cover. So, the reinforcing steel for concrete members must be protected from the surrounding environment. That is, fire and corrosion protection need to be provided. And to do this, the reinforcing steel is located at certain minimum distances from the surface of the concrete so that a protective layer of concrete cover is provided. So, kailangan guys maglagay ng concrete cover kasi hindi natin pwedeng i-expose yung ating reinforcement kasi magko-corrode siya or yung taya ba yun? O tatayain o di kaya magiging or protection din siya for fire. So ayun na. Okay, so the cover improves the bond between the concrete and steel. So here is the example of our concrete cover. So take note guys that a concrete cover is measured from the concrete surface. So ito yung concrete surface is measured from to the outermost surface of the reinforcement to which the cover requirement apply. So yung shrinkage and temperature bars nandito. Then, yung main bars natin is dito siya na side. So, yung concrete cover natin is dito siya. And kung yung depth natin is from the centroid siya sa ating main bars to the outermost layer. Then, yung H or yung thickness natin ng ating slab is from upper outermost layer to the lower outermost layer of the slab. So yun yung syempre yun yung thickness ng slab. Then dito na side is from the centroid or the concrete cover plus yung diameter ng bar natin all over to. So ito yung length niya dito na side. So, also, concrete cover. So, binigyan tayo ng code, ang 2015 code, ng specified concrete cover requirement. So, it is in accordance to table 420.6.1.3 of the NSCP code 2015. So, here, this is described as the non-pre-stressed cast in place concrete members shall have specified concrete cover for reinforcement at least that given in table 420.6.1.3.1. Ito na yon. So we fall under this not exposed to weather or in contact with ground contact exposure. So the member is under the slab joints and walls. So for reinforcement 40 mm diameter and 58 mm diameter of bars, so the specified cover will be 40 mm. So 36 mm diameter of bar and smaller, the specified or 36 mm bar and smaller reinforcement. So the specified cover would be 20 mm diameter. So that's it for the concrete cover. So in continuation with my presentation, let's have the basic steps in designing a one-way slab. So first is, let's choose slab thickness to control deflection rather. So under the step 1, we have the code has given us a minimum slab thickness. So first, we have a 4 support condition. First is the simply supported, which is given with a minimum slab thickness of L over 20, which is itong L na ginamit nato is that ito siya, yung length perpendicular sa longer side. So ayun siya. The second one is 1 and continuous. 1 and continuous. So under 1 and continuous, if yung given or i-design natin is that yung side A, B, D, E, so ang ginamin na is 1 and continuous, which has a minimum slab thickness of L over 24. So another support condition is the both end continuous. So under both end continuous is that dito, pag i-design natin yung DEGH, so it means continuous siya dito, then continuous din siya dito. So ayun, yun yung both end. So kasi pasensya nila yung writing ko, which is the minimum slab thickness is L over 28. And lastly, for the cantilever, so we already know what is a cantilever, diba? Di na natin na i-review. Cantilever with the formula of L over 20. So itong mga formula na to, yung in finding a minimum slab thickness, this is only applicable if Fy is equal to 400. Fy is equal to 420. And if Fy is higher than 420 megapascal yan, MPa. So we will use, the expression shall be multiplied by 0.4 plus Fy over 700. So this expression will be multiplied at the given support condition na height. So ito, if the support condition is simply supported, so ito ay multiply mo lang dito. So makukuha mo na yung minimum. So ayun na. So tapos na tayo sa step number 1. Check na natin yan. So our second step would be check if thickness is adequate to shear. So in checking for if thickness is adequate to shear, we need to compare the maximum shear or the VU max to the desired to the concrete design shear strength. We need to compare it to the concrete design shear. We need to compare it to the concrete design shear strength, which is the PVC. And take note that the maximum shear must be less than the PVC. So in solving for the maximum shear, so the code has given us tables of formulas in solving for an approximate shear in one-way slab in beams. So first we have the location at exterior face of first interior support. So ito yon. So kung ito yung slabs natin, then ito yung column, ito yung exterior face of first interior support will be located at this side and this side. And then yung VU natin will be 1.5. In solving for VU would be, so ito yun, yan, VU would be 1.5 of our factored load times the clear span all over 2. So the face and the formula for face of all other support would be VU is equal to W factored load Ln over 2. So ayun. So depende siya sa problem kung ano yung given niya or ano yung hahanapin natin. I-compare natin yan, itong VU max, i-compare natin yung solution sa VU max, i-compare natin siya sa solving i-compare natin siya sa result sa PVC. Yung formula ng PVC is equals to P where is it? P times 0.17 lambda square root of FC prime B OBD, which is yung value ng lambda natin is at normal weight we have 1.0. Then yung fee natin sa 2015 we have 2015 na code we have 0.75, and sa 2001 na code, sa 2001 na code we have 0.85. So after solving this, makuha na natin yung PVC, and we found out na VU max is less than PVC. So let's proceed to calculating the positive and negative moment slab. And pag dili siya, pag VU max is greater than PVC, so we need to redesign our slab. So that's it. So check na siya. Alam na natin yung step number 2. So after checking if thickness is adequate to shear, so step number 3, we'll proceed to step number 3. And in step number 3, we're going to calculate the positive and negative moment in slab. So in calculating the positive and negative moment in slab, so masyadong mataas yung table niya since binigyan tayo ng code in solving for a positive and negative moment in slab for one-way slab and for the beam. So i-present ko na lang siya through PowerPoint presentation para mas clear siya at saka mas madali siyang maintindihan. So that's it. So let's now proceed to step 3, which is the solving for calculating for the positive and negative moment of the slab. So the code gave us this shortcut or this table, or the approximate moments for non-pre-stressed continuous beams and one-way slab, table 406.5.2, in solving for the positive and negative moment. However, di tayo makakasiguro na magamit like magagamit talaga natin to. So first is we need to meet the criteria in order for us to use this table. So first criteria is members are prismatic. So it means that all members or all beams must be in equal sizes. Second is loads are uniformly distributed. So alam naman natin kung ano yung uniformly distributed, di ba? Like from the beginning to end, so na-distribute siya uniformly sa span niya. Then another is yung live load or L must be less than or equal to 3 times the dead load. And another is there are at least 2 spans. So alam naman natin yung spans. Na-discuss ko na yun kanina. So yung spans is like dalawang span siya for one way, then more than 4 ata siya for two-way or 4 siya jud. So then the longer the two adjacent span, lastly the longer the two adjacent spans does not exceed the shorter by more than 20%, or yung formula nito like the longer span minus shorter span divided by the quantity niya divided by the shortest span must be less than the 20%. That is how we're going to calculate for the positive and negative moment of slab using this formula. So it will be further discussed in the example later, so by another reporter. So ayun nga.
So now we already know how to calculate for the positive and negative moment in slab. So check na yan. So now the calculated value we have from solving the step number 3, we will use it in designing the reinforcement for moment. So yun na nga. So alam naman natin yung value na makukuha natin dito and yung sa design of reinforcement moments na i-compare natin. Siyempre pipili tayo ng value or pipiliin natin yung mahal natin. Ay, doon na. Joke. Then yung value na makukuha natin doon is like pipili tayo kung asan yung smaller value for spacing. Then we all know that the closer the spacing of reinforcement is, the stronger the slab is. So yun na yun. So in solving for the design reinforcement for moments, we have to solve for the steel ratio or the rho. So rho, make sure that the rho must be less than sa steel ratio maximum or the rho max. In solving for the rho, or the steel ratio, it is equal to 0.85 over F1. So, magulit lang kung units guys, kaya di ba kung memorize. Hindi ko kasi kung ano si Sir Alat Lodi 1 minus 2Rn over 0.85 FC prime. So, yan yung formula niya. So, ito, given niya lahat. Yung FC prime, given niya. Yan. And then, ang di lang given is yung Rn. So, para masolve natin yung rho, we need to solve first the Rn. So, Rn is equals to yung calculated value natin sa moment slab, either, or isolve natin both yung positive and negative moment. So, mu is equals to, yung mu is either positive siya or negative. So, pero isolve man natin both. Mu is equals to P 1/3. Yung P natin na gagamitin yan is 0.9. So, ayan. So, kung makuha natin yung RN, so, makakalculate na natin yung fill ratio or yung actual raw. So, in solving for the raw max, so raw max is equal to 3/8. Yung formula niya, equal to 3/8, 0.85 FC prime and beta 1 over Fy, which is yung beta niya is 50. So in solving for beta prime, so if beta prime is equal to 0.85 under condition if FC prime, given na FC prime is lesser than or equal to 28 megapascal. So if beta 1 if FC prime is greater than 28 MPa, so greater than yung solution natin beta 1, it must be bigger value of ito na formula 0.85 minus 0.05 over 7 times FC prime minus 30. Bigger value, nasolve din yun eh, then n 0.65. Yun yung solving or conditions para makuha natin yung beta prime. So, yun na nga, after getting the raw max, compare natin to. If raw is less than raw max, then okay siya. If yung design niya, then mag-proceed na tayo na another step. If raw is greater than raw max, so we design. We need to redesign. So after checking for the raw max, or after comparing the steel ratio to the maximum steel ratio, so diba, compare na to siya. So now we will proceed on comparing for the minimum. Pero minimum natin dito is that yung minimum na area sa steel, which is yung raw, yung solution natin nakuha natin ganyan, or calculated value na nakuha natin kanina sa raw is magamit natin siya sa area sa steel. So the area of steel is just, so in comparing the area sa steel sa minimum area sa steel, first is area sa steel. So area sa steel is just raw times the area gross, or the BD. So in solving for ES mean, so we have two conditions. So that two conditions would be if Fy is lesser than 420 megapascal, so AS min or AS minimum will be 0.002 of the area gross. And if Fy is greater than or equal to 420 megapascal, so our AS mean should be greater of greater of ito 0.0018 times 420 times the area gross all over the FY, and also 0.0014 of the area gross. So, ayun na. So, after that, we will compare. So, if yung area sa steel natin is lesser than AS minimum, or yung calculated na value natin sa AS minimum, so let's use AS minimum. And if AS is greater than or equal siya sa AS min, so kabaliktaran, use AS. Ganun lang. So, ayun. So, in solving for the AS, so kung makuha na natin yung AS natin, so we will now proceed on solving for the spacing of the reinforcement. So, erase muna natin ito. Yan. So, we will proceed on solving for the spacing of reinforcement. So, yung formula ng spacing for reinforcement is that spacing is just equal to yung area sa bar natin o yung bakal na gamiton or over AS o yung calculated value ng AS natin compared to AS minimum. So, kung saan yung mag-govern yung gamitan natin AS sa steel times 1,000. Itong 1,000 is yun yung 1 meter strip na i-design natin. I-design natin sa slab. Then, ayun na nga. So, after makuha natin yung spacing of reinforcement, so, kung meron tayong value nito, so we will now compare it to the table given by the NSCP code, the table 407.7.2.3, which entails that S must be greater than 50 mm, and S must be less than 3H. Yung H is yung slab thickness natin, and 450 millimeter. Transverse direction shrinkage and temperature bar. And temperature bars. In solving for the spacing of transverse direction shrinkage and temperature bars, so, present ko na kanina, yung rho must be equal to yung area sa steel over BH. So, just kung kukunin natin yung AS para magamit natin sa spacing later, so AS is just rho times BH. So, diba, yung sa spacing kanina ng reinforcement, yung AS natin is rho times BD. Iba siya sa spacing dito sa transverse direction and shrinkage temperature bars. So, ayun na nga. So, after solving for the ES, so, we will use this calculated value of AS in solving also for the spacing. So, spacing is, balik ko na ako, yung area sa bar, ang bakal na gamiton, over area area sa steel or yung calculated value natin dito times 1,000 millimeter or yung 1 meter strip na i-design natin sa slab. So, yung calculated value natin dito sa spacing, i-compare natin siya sa yung condition na naman, yung condition niya. So, dapat ma-meet niya yung condition which is, yung condition niya is S must be greater than S must be greater than 50 mm, and S must be less than the calculated value of diba spacing sa reinforcement 3H, dito we have 5H or 5 times the slab thickness and the 450 mm. So, yun na yun. So, that's the end of designing for reinforcement. So, yung spacing na nakuha natin dito, yung gamit yung calculated value ng positive and negative moment. So, yun yung i-compare natin. And the lesser or the closer the spacing or the lesser the spacing is mas stronger yung ating slabs. So, ayun na. So, that's the end of the basic steps in solving for on designing a one-way slab. So, thank you.